Heat set inserts are a great way to connect 3D printed parts together with screws. They can be a little tricky to use at first, but once you get the hang of them, you'll be creating secure enclosures and mounting electronics in no time. I'll show you how to design the right size holes for them in FreeCAD using the hole tool, and then how to actually put them into your 3D printed parts. Let's jump in. Previously, we looked at creating sketches, making features from those sketches, and how to use shape binders to create mating parts. Now, we'll talk about making such connections more secure using heat set inserts. Heat set inserts are typically made of brass with a knurled pattern on the outside and threading on the inside. The basic idea is that you heat the brass so it melts the surrounding plastic as you push it into a hole. Once the plastic cools and returns to a solid, the insert is held securely in place. At this point, you can attach parts together using screws with threading that matches the inserts. There are a number of ways to connect parts when you're 3D printing, like snaps or glue. You can also add threading to the hole in the part itself, but I find this easily breaks when you add screws. My personal recommendation is to use heat set inserts when you need a secure connection that can be taken apart. In some cases, you'll find heat set inserts that come with datasheets showing you the exact dimensions of the part and hole you need to make. Other, often cheaper inserts just tell you the dimensions of the part. In this case, we have to guess at the hole dimensions. M3 is a very common screw size to use for 3D printed projects, and you can get bags of inserts at this size from Adafruit and DigiKey. I'll be demonstrating this process with an M3 insert that is 4 millimeters long. Generally, the longer inserts will offer more strength as there are more threads for the screw. The outer diameter of the knurled section is 4.2 millimeters, and the outer diameter of the smooth section is 3.75 millimeters. If you don't have the recommended hole dimensions, CNC Kitchen has a great blog post on how to design 4 inserts with this sizing chart. In general, the hole diameter should be large enough for the smooth section, but smaller than the knurled section. They recommend 0.1 millimeters larger than the smooth tip outer diameter, which would be about 3.85 or 3.9 millimeters for my part. The hole depth should be at least 1 millimeter longer than the insert, which would be 5.2 millimeters for me. This extra millimeter provides some space under the insert to allow the melted plastic to collect without squishing up into the threaded section or out of the sides. Notice that we should have at least 1.6 millimeters of material around the hole to create a sturdy wall. In FreeCAD, make sure you are in the Part Design workbench, go to New Document, and we're going to click New Body to create a body inside of that document. Click Sketch, and we're going to sketch on the X and Y plane. Click on the Rectangle tool. We're going to create 2 rectangles to make our posts. Right-click, and then we're going to create 2 horizontal lines connecting the 2 inner points of the posts together. Notice that the horizontal constraint was automatically set since those lines were created more or less horizontally. If those are not set, if you do not see that little icon there, you'll want to click on the constrain horizontal and then click on each of those lines. I'm going to right-click to get rid of that tool. Next, let's take this and make it symmetrical around the origin. So I'm going to click the outer 2 most corners and click the origin. So now it's symmetrical about the origin. The width and length of these posts should be equal, so I'll press E, set these constraints to be equal, and looks like they are now equal, except for that part. So let's make this top one equal with this top post over here. Now those should be equal. So I just have the 2 degrees of freedom that are the length and width of the entire part. Let's set the width. So I'm going to press D for this Smart Dimension tool. I'm going to click on this line here, drag this dimension out, click. I'm going to use the expression editor. I'm going to set it to 3.9 millimeters, which should be the diameter of that hole. And I'm going to add some walls around it. That's going to be 2 times 2 millimeters. So that's going to add 4 millimeters around that hole. Click OK. So let's click those 2 points on the top part of this sketch, and I'm going to set the length to 40 millimeters. Right-click to exit that tool, and we should have a fully constrained sketch. Click Close to get out of this. We could extrude this part and then extrude the posts. but I'm going to demonstrate a slick new feature with version 1.0 or 0.22, depending on what you're working with. We can actually select individual lines and extrude them individually. To do that, I'm going to select the lines. So click to select each of the lines while holding Control, and we're going to get this entire rectangle. I have to start over again because I accidentally clicked out. There we go. So I've got the entire outline. I'm going to pad, and I'm only going to pad 2 millimeters. Now we're going to create 2 separate pads from one sketch. So let's hide this pad, drop it down. Let's show the sketch. Click to not select the entire sketch. Now I want to select each of these lines for the posts. So click on one, hold Control, click on the others. This one might be tricky to select if it's trying to select the whole thing for you. So zoom in if you need to. It looks like there's actually 2 lines here. So I'm going to zoom in to where I can just select that one line. I'm going to select, oops, not that one. And it makes me start over. So let's select each of these. Notice it's trying to get me to select the whole sketch. There we go. Make sure I'm just highlighting this yellow. Zoom in and out if you need to. So I'm just selecting this line. It looks like that one is selected. This is super interesting that it's trying to have this whole line selected. Let's see if I can fix this in the sketch. So I'm going to come to this sketch. If I get rid of this line, that's what's going on. It looks like there is an entire line that's connecting. So let's get rid of that line and let's redraw these as basic lines. I'm going to click on each of those lines and delete them. I'm going to come back in with the line tool and I'm going to draw separate lines for these segments rather than going all the way across. That looks like what happened here. I'm going to just draw these lines here and here, like so. Right click, I have 1 degree of freedom. So it looks like that can move. I'm going to press E, set this equal constraint between those two, right click, fully constrained, and we are done. Now the pad is broken because we deleted those lines. So to fix this, if I tried to show this, it looks like it's working, but this little icon here means that something's wrong with this pad. Let's try recreating this pad. So I'm going to delete that pad. So click on it, press the delete key. So now we're back to this sketch, and I'm going to click to unselect this sketch. Then I'm going to click on the outermost edges. So Control click all of my outermost edges. So we shouldn't have any overlapping lines anymore. This is going to make this process much easier. I'm going to pad, make that 2 millimeters, click OK. I'm going to hide the pad, show the sketch underneath that pad, select that sketch and press space to show it. Now let's select my posts again. This should be much easier without those overlapping lines. There we go. That was a lot easier. Now we're going to click pad, and it's just going to pad those. And you notice we did this from the same sketch. So I'm going to use the expression editor. I'm going to set this to pad.length, which should be 2 millimeter, and add the gap here that I want, which is 6 millimeters. Notice that I can't just use 6 here. It doesn't infer units. I actually have to say mm for millimeters to give it specified units. So click OK, and now we've got the nice gap between our posts and between the bottom and top layer of our part here. Click OK to exit out of this task, and we have set that pad. We need to put holes in each of these for our heat set inserts. One way to do that is to create a sketch and put 2 circles here and then use the pocket tool as we saw in the previous episode. Or I'm going to click on face and I'm going to try the hole tool. Notice that it did not give me a hole here. So that means it's not trying to drop a hole. That's a problem. So let's cancel that. And I believe we need some sort of sketch to act as reference. So let's create a sketch on this plane as we did. Feel free to actually make the correct size hole here, but I'm going to bring in this reference geometry here and here and here and here. Let's create our sketch here. We need to constrain that to this axis here. So click C for the constrained coincident tool, which is right here. Feel free to click that instead. I'm going to click on the center of that circle and click on that axis. Now that circle can move along that axis, but not off of it. And then I want to create a distance between this and here. or we don't need this diameter to be exactly correct unless you're going to use that pocket tool. So the other thing we can use is the symmetric constraint tool and make that circle appear in the middle of this square. Right click to exit that tool. Notice I have redundant constraints here. That is because by doing the symmetric tool, it automatically assumes it's on this axis. So we don't actually need this. So look at this number here, number 1, find constraint number 1, click it and click delete. That should remove that redundant constraint for us. Now that circle is in the middle of that square and we can adjust the size. Doesn't actually matter, so I'm just going to create an arbitrary dimension here, say like 1 millimeter, right click, and we are almost done. We need another part of that sketch over there, so I'm going to drag and select that. I'm going to mirror, use the mirror tool, and I'm going to mirror about this axis. And something is very off here, so I am glad I found this bug. It looks like we have more of the bar on that side. So let's close. Let's go fix this first and then come back to that. So this is a topological naming problem. This dot was this one by name, but it got moved to this symmetric constraint. So now the origin is in between this outer point and this inner point. That's a problem for us. So we need to fix that. Let's find our symmetric constraint, which is, you can barely highlight it here. So you can either click it there or you can find it in here and click it. When you know you've got the right one, it should turn that darker green color. So click that, delete it, press S. We're going to click the outermost corners and we're going to click the origin, and that should fix that distancing problem for us. There's also a problem with the length, so let's delete that constraint. We'll push D for the distance. We're going to select the outer 2 most points, hover above so it creates a horizontal distance, and change that to 40 millimeters. Right click, and we should be fully constrained. Click close, double click on sketch 001, and now we should be mirrored in here. Notice that because we did the mirror tool, this now floats, even though the diameter dimension is set. So we're going to push S for the symmetric constraint tool. We're going to pick the outermost edges and click the center of that circle. Now we have a fully constrained sketch. Let's close out of that. Those points should be in the middle of the posts. The size doesn't matter. You could pocket them if you want to, so I'll cancel out of that pocket tool. What we actually care about is using the hole feature. So I'm going to click the sketch and I'm going to click hole. That drops a giant hole in the middle of that post. There are a number of profiles here that you can select for metric and imperial, say screws, bolts, and what have you. I'm going to use none for a custom hole since we are doing a heat set insert. I'm going to change the diameter to 3.9 millimeters, which is what we calculated from the dimensions of our part and that website by adding 0.1 millimeters to the smooth diameter of that heat set insert. Note that depth through all is probably the easiest way to work with heat set inserts because it just drills a hole all the way through. Any plastic comes out the bottom here and probably doesn't get bunched up with your tapped edges on the inside of the insert. So that's usually the easiest way to go. But sometimes you can't do that, so you need to create a blind hole. So let's change the depth to dimension. Let's change it to 5.2 millimeters, which should be 1 millimeter more than the length of the insert. Click tab to change it, and we get to see the bottom of that hole there. Notice in the tasks pane, we can come down and change the drill point from this angle to flat. Since we're 3D printing this and not actually drilling it, that's fine. And we can actually add a counter bore, countersink, and counter drill. So counter bore adds in basically a lip in there, so you could put in say a button head screw. You could add a countersink for that kind of tapered screw head, or a counter drill where it's inset a little bit and tapered. We don't need this for heat set inserts, so let's leave this to null, but note that this tool is very helpful when you're trying to create holes for things like bolts and screws. So scroll on up in the tasks pane, click OK, and we are done with that hole. So that should accept our heat set insert. We could come back to our sketch, click on that part of the sketch, and create another hole just like we did before. But I'm going to show you how to mirror a feature. We mirrored a sketch in the Sketcher tool, and now we're going to mirror a feature in the Part Design tool. This can help if you have a bunch of different features on one side and you want to mirror it to the other. So I'm going to click on that hole because that's what we want to mirror. And I'm going to click on the mirror tool, which is right up here. You can also find it in Part Design, and you can apply a pattern mirrored. So let's click on that. And you notice it automatically mirrors for us, and that is because it is moving around the vertical sketch axis. We can also pick something like the XY plane, which should mirror it to the bottom, and that's going to be way down here, so you don't actually see that. We can do any of the other planes, or you can even create your own plane using something called a datum plane, which is right here. And that's an arbitrary plane somewhere. You could select that and mirror about that if you don't want to use one of the existing planes. But we actually want to mirror around the YZ plane. So I'm going to select YZ from over here. And you'll notice that the hole shows up on this post. Click OK for our task. And we are done. The only thing I'm going to do here is click on the sketch and hide that so they're not cluttering up this view here. And I'm going to collapse my features that we've made. Now we need to create a top for our little lid here. Basically something we want to drop the screws into that attach to the heat set inserts and hold something together. Let's create a new body. And we are going to click the first body. Notice that the body 001, the one we just created, is highlighted purple. That means it's the active body, and we've selected the original body, this base, and we're going to create a subshape binder. Feel free to press space to hide that selected body. And now here is our subshape binder that we can use as reference geometry. Let's click on the top face of this binder, the top of these posts, and we are going to click New Sketch. Now we are sketching on top of those posts. I'm going to adjust my camera again so we can see what we're doing. And we are going to bring in these lines as reference geometry for us to create our sketch from. Right-click to exit that tool. In fact, we probably don't need this line. Let's see if we can delete it. Sometimes FreeCAD does not like us deleting external geometry, but it lets us highlight it and delete it, so that's good. Let's create a rectangle. We're going to go from this bottom corner to this top corner, and that should be fully defined for us because we've already defined the coincident constraints for these corners, and that fully defines that rectangle. So close out of that. Let's pad this. Let's give it 2 millimeters, and it looks like it hid that body for us. Let's bring that binder back so we can see what we're doing. And we are going to sketch underneath that top we just made. So let's hide. You can hide the binder, hide the pad, but what I really want to do is sketch on this face. Let's go ahead and click on it. Let's click on Create New Sketch, and it looks like it's coming in from the bottom here, which is fine. I'm going to bring in these holes, or just one of the holes, as reference geometry. If you can't see it, sometimes it helps to move the camera around, or what we probably need to do is view section. There we go. Now I can bring these in. That's what I want. Right-click to exit that tool, click bottom to view that sketch, and we're just going to draw a circle to line up with that. So click the middle of that circle, click the edge, and it's a fully constrained circle in there. So let's close that, and let's go ahead and hide that binder. So now we have a circle in the middle. That circle is the size of the heat set insert, which is what we don't want. We actually want it smaller so that it's the size of the screw rather than that insert. Let's use that hole tool again for its actual intended purposes, making holes for things like bolts and screws. So click the sketch, either in the tree view or the actual part of the sketch in the viewer, click the hole tool, and it's going to drop a giant hole in there for us. This time, let's go to isometric regular. We're going to change the size to an M3 screw. We want the clearance to be standard, so we can make it close or wide, which is a loose or a tight fit. Let's just go with standard for this. This time we want to go through all, that's fine. Punch it through the whole body here. And feel free to check both sides, make sure the hole looks good. Notice that we can actually thread this. So if we click threaded, click model thread, and click update thread view. The big issue here is that when it creates a tap or that thread pattern, it uses a lot of computational resources. In fact, the fan in my computer started going to do this just for one hole. And you can add threads in here. This is a slick way to create a threaded part. Because we are 3D printing, these don't print very well. But if you were going to create a tap from something else, this might be useful. So for now, let's get rid of that threading. Make sure that all this looks okay. We don't need to do any sort of counter-boring or countersinking. So let's just click OK. And now we have the hole in there. We're going to repeat that mirror tool that we did last time. We're going to click on the hole. We're going to click the mirror tool. And we are going to actually make sure the mirror goes around this YZ plane. It's the vertical sketch axis right now. But to make sure we are doing this correctly, let's do the YZ plane. There we go. And that looks pretty good. So click OK. And feel free to bring that binder back in, or the object itself. So I'll hide the binder. Let's bring the body back in. And you can see that those holes line up perfectly. We can show and hide that body, that clamp part, to see how those line up with the heat set insert holes. I'm going to show this. Feel free to save your work. I'm going to call it cable clip. This is probably the worst use of heat set inserts to create a simple cable clip, but it's a good demonstration on how to use heat set inserts. Let's save that. We'll click on the first body. We'll export it as one, and we're going to click on the next body. Click export, file export, and export that. It looks like cable clip body 001 already exists, probably from when I was trying this on my own before. And you are done with the modeling part. As we've done before, I'll import the STL files that we just made. So there's the bottom part of that clip, and here is the top part. I will import these into the slicer program and get them ready for 3D printing. Don't forget to flip over any parts as necessary to avoid having to print any sort of support, as these parts should be fairly simple. So I'll click slice, and I'll save it to disk and send this off to my 3D printer. This should be a pretty easy and fast print, as the parts are pretty small. Sometimes you'll need to lightly sand your parts or use a hand drill to ensure everything is flat and the extra plastic is cleaned out. To heat the insert, you have the option of buying special soldering iron tips. These have a cylindrical tip the exact size of the inner diameter of the insert. If you look at the datasheet, you can see that this tip is meant for Hakko soldering stations and fitted for the number 4 or M3 inserts. So you need a separate tip for each size insert. They work really well to heat the insert evenly and to prevent plastic from getting into the threads. However, I couldn't find any such tips for my particular soldering station, so I'm going to show you how to use a basic soldering iron to place the inserts. I'm going to use a flat, wide tip to help transfer a lot of heat. The general rule is to set the soldering iron to about 50 to 100 degrees Celsius or 120 to 200 degrees Fahrenheit above the melting point of your plastic. I used PLA, so that would be a minimum of 175 plus 50, or about 225 degrees Celsius up to about 275 degrees Celsius. That's a minimum of 437 degrees Fahrenheit. My soldering station can only go as low as 500 degrees Fahrenheit, so we'll use that. Put a screw into the insert and make it flush with the bottom side. This is the smooth side without the knurling. Make sure you have some pliers or other metal tool nearby. Place the insert and screw into the hole of the 3D printed part. Use your soldering iron to heat the top of the screw, which should also heat the insert. Slowly push the insert down into the plastic part. Notice that it melts the plastic along the way. Stop when the insert is almost flush with the top of the part. Quickly switch to the pliers or other tool to hold the insert in place while the plastic cools. This should only take a few seconds. Repeat this process for the other insert. Put the insert and screw into the hole. Heat the screw with the soldering iron and then switch to the other tool to hold the insert in place while the plastic cools. Once that's done, you can then use your screwdriver to remove the screws. The screws help prevent plastic from flowing into the threads of the inserts, which makes putting the screw in later much more difficult. If you're using the proper tip that fits into the insert, you can use a flat metal object like a ruler or spatula to press on the top of the insert after heating to ensure it's flush with the plastic part. This is probably the better way to attach heat set inserts, but I don't have the correct tips for my soldering station. While this is mostly just a demo object for learning how to use heat set inserts, you could use it for something like keeping cables organized. As a challenge, try changing your keepsake box or dev board enclosure to have screw holes. You can use heat set inserts if you have them, or just do threaded holes in FreeCAD. The Raspberry Pi uses M2.5 screws for mounting, and the Arduino uses M3 screws. Don't forget to share your designs on X, Instagram, or LinkedIn with hashtag DKFreeCAD and tag DigiKey. In the next video, I'll show you how to use the gear tool along with feature patterns and Boolean operations to design a custom servo motor disc. Until then, good luck with this challenge.